Here are the solutions for Chapter 13. How did you go? Was that tricky? Alright, let's look at that first question that I posed to you. The typedef int star int underscore p semicolon. What does that mean? Well, it means create a new type. That's what typedef is all about, type define. Create a new type that is a pointer to an integer. Call it int underscore p. That'll be the name of the new type, int underscore p. Confusing line, isn't it? Well, anyway, that's what it means. How many of you got that? Next line, int underscore p, p. Declare a variable called p of this type. P will be a pointer to an integer. Now, notice that p is a pointer, even though in its declaration there is no asterisk. You might think, well, hang on, there's got to be an asterisk in the declaration of a pointer. No, there doesn't. Well, if typedef has been used to declare that type. So if you like, the asterisk is part of the declaration, but it comes from the typedef line. It is a little confusing. Anyway, that's what those two lines of code mean. Let's now go and have a look at the code and find the solutions to those exercises that I posed to you. This is a file called pointers.c in the solutions folder. I'm actually going to use this one program to solve the two exercises that I gave you, the myscanf exercise and the print-in-pointer exercise. They're both solved in this particular source code file. First of all, we'll have a look at print-in-pointer. Okay, it takes a single integer pointer, or a single address of an integer as its parameter. Then it prints out that address. That's very, very simple. I know that it might have been tricky for you to figure out how to do that, but the actual result is very simple. Print out the address. The address can be thought of as an integer, some large number, and this is that number. Then print out the value at that address, which is also an integer because it is a pointer to an integer, remember, and that's just, well, the contents of p, or the thing that p points to, or the value of the thing that p points to, depending on how you like to say it. So that's how print p pointer will work. Let's go and test that. Well, my scanf is there as well. I'll cover that in a second. Please enter a number, and then we're going to print out that number here. So let's try that and run it. Please enter a number, 34. Okay, so a few things are going on here. First of all, the myscanf, that happens to be working as well, because we finally got the value at the address as 34. Now, so we've got the integer x. Let's have a look at that. Just drag that away. The integer x here contains 34. That's pretty clear. Now, the address of x is this value, 39,058,900. So when we pass that integer into print-in-pointer, or rather we pass the address of that integer, x, that address gets printed out and the value itself gets printed out. What would have happened if we'd simply passed in x itself rather than the address of x, if we changed print-in-pointer such that it didn't require a pointer to an integer on its parameter line, but rather just required an integer? Well, obviously it would still print out 34. What about the address? Would the address be the same or different? Let's say we figured out how to get the address of that parameter printed out as well. It's not that hard. I mean, you can just do a printf, and the number that you print out would be the address of the parameter, ampersand parameter. The question is, would that address be the same as this address? The answer is no, it wouldn't. The reason is that the parameter is a different parameter. It's not the same as x. The parameter is a duplicate, so it would be the address of a duplicate, not the address of the original x. Okay, now let's go and have a look at myscanf. So here's myscanf. This is how I'd like it to work. I simply pass it, well, the integer that I wanted to read in. Now, just like scanf, remember scanf, you have to use an ampersand whenever you want to read in an integer from the keyboard. Just like scanf, we have to do the same thing with myscanf. We can't just pass it x, because if we did, myscanf wouldn't have a hope of being able to modify x, because functions can't modify their parameters. So of course we have to pass it the address of x. So here is that parameter. It's a pointer. I've called it the int. It's not a very imaginative name, but I couldn't think what else to call it. I could have called it pointer or something like that, but I'd really like to show by my naming of the variable that it is an integer. I know it's a pointer, but I'd like to think of it as an integer. So then I pass it to scanf. Now, notice here that I do not use an ampersand here. I don't. How many of you tried that? How many of you thought to yourselves, well, whenever I use scanf, I have to put an ampersand on that parameter? I know a lot of you would have done that. It's not going to work. That's why I wanted you to test this. Because if you tested that, you would have found that it probably would have crashed your program, to be honest. That is wrong. Because what scanf actually requires is the address of an integer. And that's what we've got. We have got the address of an integer. That, the int, is actually the address of an integer. Now, you could write this line out slightly differently. You could write it out like this. Well, what we would have had here, typically, in a scanf line would be an integer. And that is an integer. And then we can take the address of that. So we can say take the address of the contents of the pointer. Now, that's exactly what's going on. That's being fully explicit. But obviously that's redundant. It's like a double negative. The address of the contents of is silly. We just can get rid of both of them. They cancel each other out. So that will work. And we've already tested it. We've seen that it actually does work. So this is a handy little piece of reusable code. Calling myscanf is obviously like that, is much simpler than calling scanf, which is like that. Not much simpler, but it is a little bit simpler. So you could use myscanf now, from now on, if you ever wanted to do a scanf of an integer. Notice, of course, that it will only work for integers. Okay, so that's that. Now, what about the project, the course project? Let's go and have a look at that. Okay, here's the project. Here's our 5 files in the project. I guess first we should have a look at database.h. Let's see how that's changed. The only change that I've made in database.h is I've changed a couple of prototypes. And the only ones I've changed are these two, readcd and printcd. Printcd used to take a CD type, which is of course just it's shorthand for that, a CD type, and it used to take one of those. It used to look like that. Now I've just changed it to look like that. So it takes a pointer to one of those now. So it's going to make our program more efficient. And readcd, similarly, now it no longer returns a CD underscore T. It used to do that, but I've just now made it return a regular integer, even though it doesn't really return anything at all. And I've caused it to take its CD as a parameter. It is going to modify this parameter. It's going to read the details into the parameter that it gets passed. And of course it's able to do that because that parameter is a pointer, or it's in the address of the CD. Okay, that's the only change I made there. Let's have a look at main.c. Here's main.c. Now there's very few differences made here. The only differences that we introduced were to account for the, where are they? The reading in of CDs. This is a slightly different line now. We're actually now passing in the address of that. We're passing in the address of one of the elements of the CD array. How many of you got that? Now if you got that bit, then you'll get this bit as well, because that's exactly the same. And it's nice that it's exactly the same. It makes our code a little bit more consistent. Those are the only changes in the main.c. Okay, let's now have a look at output.c. Output.c has changed a little bit because printcd now takes a pointer to a CD, not a CD itself. It used to just take that, now it takes that. So now that we've done that, we need to go through the CD program, the CD function, and change all the references to the fields instead of being CD.title to CD arrow title, like that. 1, 2, 3, 4, 5. The fourth one is there. And that's the only changes required for printcd. Okay, let's Let's close that and have a look at input.c. Input.c has changed in almost exactly the same way. None of these little enter and yes no functions changed at all because they don't refer to structures. Read int, read float, read string, they're all the same. But read CD has changed. It now no longer takes, well, it used to take no parameters, now it takes one parameter. It used to return a CD, now it doesn't. And it used to have its own little local variable, which was CD underscore T, and that was CD like that. But we got rid of that because we don't need it, because it's being passed in here. So we don't need a duplicate. We can work on the original. And again, CD arrow title instead of CD dot title, and so on. And there, and you don't need a return statement because we're not returning anything. And that's all there is to it. utils.c didn't change at all because the only thing that's in that is the thing to trim out the new lines out of a string. That obviously has got nothing to do with structures. Okay, so let's compile this and see if it works. Compile, no errors throughout the whole project, that's good. And run, and well, it works. Believe me, it works. I won't bother going through that. Okay, excellent. So that is the chapter on basic pointers.